guys, today in this lecture I would demonstrate to you that how can we write the electric field and electric potential due to a system in which there are concentric spheres. This is a quite simple concept, but it is giving some monstrous feeling to some students. So to demonstrate them how to write the electric field and electric potential, I am taking an example here. So there are three spheres. These three spheres. Its first radius is A, this radius is B, this is C. Charge on the innermost sphere is Q1, Q2 and Q3. All are positive. Okay. So there are some points. This is A, this is B, this is C and this is D. And also RA is greater than, is in fact less than A, RB is greater than A but less than B, RC is greater than B but less than C, and RD is greater than D, in fact C. So these are the locations of these points. We have to calculate potentials and fields at A, B, C, D. So first of all, I am telling you how to write electric field at these points. So electric field at point A. So what is the trick of writing the electric field? The trick of writing the electric field is the fact that, let us suppose we have to write the electric field at point A. So we can assume a sphere whose surface contains A or whose radius is RA, and we can find out the charge inside that sphere. And you can see that A is the innermost point of the system. Hence, if we assume a sphere whose radius is RA, then there would be no charge inside that sphere. So for A, electric field will be 0 as Q inside is 0. For B point, if we assume a sphere like this, whose radius is RB and who is containing the B point on its surface, then the charge which will residing inside that sphere will be Q1 only. Q2 and Q3 are outside that sphere, you can see. So Q2 and Q3 are outside that sphere and Q inside is Q1. So if we are able to calculate Q inside, we have to write the electric field as K Q inside by R square. Okay, so it would be K Q inside is Q1 by R square. Here Q in is equal to Q1. Now EC at point C. If we assume a sphere of radius RC, it is containing charges Q2 and Q1 inside it. Hence we can write K Q1 plus Q2 upon R square. Q in is equal to Q1 plus Q2. And at point D, we can write the electric field as K Q1 plus Q2 plus Q3 upon R square, as this sphere is containing all the charges. So this is the simplest way to write the electric field in the system of concentric spheres. Now, but this is not applicable for writing the potentials. This trick is applicable for writing only electric field, because due to the fact that at some point, like on this point, the outer sphere is not contributing an electric field. At this point, electric field is only due to the spheres which are present inside this sphere. But in case of potential, outer spheres also contributes inside them for potential. For example, at point A, VA. So we have to see that the point at which we are writing the potential is having any sphere inside that point, or it is having all the spheres outside that point. What I mean to say, that if we draw a sphere of radius RA, then it does not contains any sphere inside it. In fact, all the three spheres are outside that point. So A is the innermost point of the system, and at the innermost point, the potential due to all the spheres is that due to this sphere, smallest sphere, it would be kq1 by its radius. Its radius is A. Due to that sphere, this one, it would be kq2 by its radius of the sphere due to which we are writing the potential. So we are writing the potential due to middle sphere. So its radius is B. So kq2 by B plus due to that third sphere, it would be kq3 by C. So VA is kq1 by A, kq2 by B, kq3 by C. Okay. Now at point B. B is lying inside these two spheres and B is lying outside this sphere. So first we are writing the potential at B due to the spheres which are lying outside the point B. So at point B, potential is equal to, due to these two spheres, due to this sphere, potential is kq2 by its radius B plus due to bigger sphere, it would be kq3 by its radius C. But due to innermost sphere, B for that smaller sphere is an outside point. B is lying outside the smaller sphere. Hence, when we write the potential due to any sphere outside it, then we have to take kq by r distance, where r is the distance of that point which is lying outside the sphere from the center of the sphere. So when we write the potential at point B due to this smaller sphere, it would be kq1 by this distance. This is RB. I hope you understand this concept. I am writing the potential of C also like that. So now C contains these two spheres, this one inside it, and this bigger sphere outside C. So first we are writing the potential at C due to largest sphere of radius C. So it would be kq3 by C. We have already discussed this thing. Plus, now one thing is important, that when we are writing the potential at C due to its inner spheres, we can sum up their charges. And why I am saying so, that if we write the potential at C individually due to these two spheres, we would say that due to smaller sphere it would be kq1 by rc, and due to that bigger sphere, middle sphere, it would be kq2 by rc. So taking k and rc common, it would be kq1 plus q2 by rc. kq1 plus q2 by rc. That is C. Now potential at point D. D is the outermost point of the system, and if we draw a sphere containing D, then all three spheres are lying inside that sphere. Hence we can sum up the total charge of these three spheres, and we can write that the potential at D is equal to k q1 plus q2 plus plus Q3 upon divided by RD. Okay guys, I hope this is a very small, simple concept. I hope you understand. Thank you, keep watching. Please do not forget to subscribe the channel. Thank you.